Hey guys and gals, how you doing? How do you do this fine day? Yeah, beautiful, intelligent peoples. Let's go. Thank you so much for hitting the play button. Let's go. Yeah, you're so awesome, so awesome. I love it. I love it. Thank you for being here. Parents, for those parents that are homeschooling their children, I'm here to help, here to support if you need it. I know you may have lots on your plate, but yeah, definitely hope you find the channel, here to help support you in your decision. That's amazing. Also, for students, if you're looking for any additional help or mathematics support, I am here for you as well. All right? Being awesome, awesome. Just like you guys are. Awesome, awesome. I love saying that. So, again, I'll kind of add, if you need any extra additional support in whichever area of mathematics you're working on, I don't know, I'm not certain. Let me know a couple of things, which topic it is, and which mathematics book that you're using, which version, and volume and such. Yeah, just keep it simple, basic information. I'm going to see, because there are some PDF textbooks that you can download. I got a couple already. I'm just not certain, well, I'm not 100% certain which textbook I should kind of follow. So, I don't know. We'll see how it goes. One seems to be a little more advanced than the other, but that's okay. I don't mind kind of I'll work out of both if I have to. Excuse me. So yeah, let me know down below in comments. And again, let's continue. Let us continue. We are working this area, this unit 3, measures of area. We, for the most part, have been working on calculating the two-dimensional flat plane surface area of a square, of rectangles, and such. And we've been talking about a lot of different things. Again, guys, gals, if you're dropping by for the first time, check out the beginning video of the series. I do my best to give a lot of mathematical tips and tricks to help speed things up, and yeah, and simplify it as well. So yeah, doing my best to stay on topic and try to be kind of quick. Doing my best. So let's continue. So yeah, okay, let's finish with the pi definition. What is pi? We never really did finish that. Okay, so Wikipedia has a what is pi. Let's see, anything? Yeah, I think we're gonna be okay. I'll just kind of share this. Wikipedia, great source. Okay, that's what I wanted to mention, that it's a mathematical constant, guys and gals. It's like the ratio, right? You could take the radius and the circumference of a circle and divide those values between each other, and you'll end up with pi. Now, another thing I wanted to quickly mention is this fraction here that I should have been a little more clearer. This is kind of a close ratio representation of pi, but it's not accurate. So if you actually calculated it, you won't get this value here. This is the most accurate value of pi, and there's a lot more digits. Give me a sec here. I'm gonna go kind of in my older mathematics book here. I think I had a definition of pi here somewhere. Let's see if I can find that. If not, we'll carry on. Because over the years, a lot of people have been trying to, a lot of the geniuses of the world, you know, those with IQ higher than 120, have been kind of trying to figure out, you know, maybe some, like this, for example, this fractional representation of pi. Okay, where was that? Getting into radicals here. I don't think pi was in this, was it? Integers. Maybe it's a little further. I don't know. Rational numbers. Radicals. Irrational numbers. Maybe in this section? No. Yeah, I think I might have found it, because pi is an irrational number. Right, mathematicians have proved that no matter how many decimal places are calculated for pi, the representation will never terminate or repeat. Okay, therefore pi cannot be expressed in the form of m over n. Now, I know we haven't really talked about that, but they're talking about a fractional m over n, essentially, where m and n are integers. Okay, we haven't really talked about integers much, but integers, you know, negative, well, we have a little bit. Of course, we kind of want to talk about integers, right? My integer graph, that's kind of what I'm talking about. Where m and n are integers and not equal to 0. Okay? Well, n cannot be equal to 0. Because any fraction or any fraction, yeah. Sheesh. My bad, guys. Any fraction that is divisible by 0 is undefined. Okay? They call that undefined. Okay? That's why n cannot be equal to 0. Okay? Now, where is that information I had on pi? I swear it was right here. Here we go. The history. I should have scanned this. Okay? Anyways. Darn skis. I'll just read it. I should have scanned it. Anyways, from ancient times, people have known that the circumference of a circle, which is basically the perimeter, you can liken it to the perimeter of a square or a rectangle. Okay, it's the same thing, except, of course, circumference refers to circular shapes. Okay, I'm trying to get my bearings here, guys. I really am. Okay, so knowing that the circumference of a circle is more than 3 times its diameter. Okay? More than 3 times its diameter. Alright, that's where that value is coming from, the 3. Okay? Through the centuries, different civilizations have tried to find a fraction that would be exactly equal to the ratio of circumference divided by diameter. About 1700 BC, the Egyptians used the fraction. Let me just go like this. Okay, so with that explained, we'll kind of, this is more advanced a little bit, but that's okay, it's not too bad. Okay. Let's see, that fraction is, so 1700 BC. Okay, Egyptians, the fraction they came up with is 256 over 81. Okay, to approximate this ratio. Okay, around 220 BC, the Greeks. We'll just go like this. Egyptians, Greeks. Okay. Use the Greek letter pi. Okay. They're the inventor of the symbol to represent this ratio. And they use the fraction right here, this one here. Okay, which I should remove because 22 divided by 7, it's close, but it's, you know, it's 3.14, but these digits here are not the same. Okay, and they use this sorry guys, whew, man, must need more coffee. And they use the fraction 22 divided by 7 as its approximate value. Okay, in their search for the elusive rational number equal to pi, various other civilizations used these approximations. So I have a few more here. The Chinese culture, date 470. Their ratio was 355 over 113. Hindu culture, $530. Whoops. Okay, we're just kind of going over a little bit of history, guys. Quite a bit of difference. That's, man. I think you want to reduce the fraction a little bit there, guys. Of course, 1250 doesn't go into that. That's a huge difference. But then also European. So I'm just going to erase this. I mean, the ratio the Greeks came up with the closest, lowest n over n ratio. Also, the inventors of the symbol pi, 32. And then European, I just kind of ran out of room here, so that's what, goodness gracious, that's why I erased that, guys. I just thought I would write that, oh goodness, thought I would write that down just to kind of share the information with you. I didn't think I was going to be doing this, so I almost wish I scanned it. Okay, 12. Now you gotta realize the time frame here. 1220. Date. I don't know if that's BC. That must be BC. I'm assuming. Their ratio was 864 over 275. Okay. And this is the Greeks. I need a little more room here. Okay. All right, we'll just leave that like that. Good enough. So I found it. Again, like I said, guys, when we're talking about a ratio of m over n, which these all are, they're referred to as rational numbers. Okay. Anything else? I think that's it. Okay, again, just like I said, mathematicians have proved that no matter how many decimal places are calculated for pi, the representation will never terminate or repeat. Therefore, pi cannot be expressed in the form of m over n, where m and n are integers, and n is not equal to 0. For this reason, pi is called an irrational number. We'll talk about rational, irrational numbers another time. I just put my older math book away, guys. So yeah, a little bit of history, I guess, which is kind of cool. Fun facts. I kind of have no choice but to erase all this. Okay, so I think that's it. With that said, I'm going to have to erase that as well, because that's a misrepresentation. Okay? It's close, but no cigar, as they say. All right, time to get into some work. There we go. Okay, all right, guys. Let's work on some more problems. We're going to just keep it easy. Keep it basic. Again, the formula area of a circle is pi r squared. If you're given a diameter, you have to basically simply just divide the diameter, which is, the diameter is point to point. Okay, that's the diameter. So the radius is half of it, right? D divided by 2. Okay? Alright, let's see. Get my formula sheet here. And go here and here. I'm trying to speed it up here, guys. Where is that? I'm close. I'm close. Here we go. Okay, there we go. Okay. So, just to share the formula sheet with you guys and gals, all right here. We don't have to worry about perimeter. I mean, I don't know why it even says perimeter. What is that? What is this? I'm not certain. Oh, maybe for this. Oh, okay, I see. Perimeter of a half a circle. That's what that is. Okay. So we're talking about a full circle here. And there's our formula sheet. I need some coffee and we're going to carry on. All right. Turn down the music a little bit. I was a little worried that it might have been too loud. It's hard for me to tell when I'm streaming, guys. I just can't tell unless I'm actually listening to the stream. So I literally turn it down as much as possible, almost to mute. That's how low I turn it down to on YouTube. Okay. So we're just going to do, I don't know, a random one. Okay? let's say we're given 4. Did we already do that? We did, I think. Let's pick something else. Let's do, I don't know, we just need some new numbers. Let's go 3.6, okay? Call it meters. Okay, it's quite large. It's quite a lot. Recall, guys, okay? Meter to feet. Well, I don't need feet and inches. It's 3.28, right? Remember that? 3.28 feet, so 3 1/4, so 3'3" and 3/8 to be exact. Well, not exact, but really close. That's 1 meter, okay? 3'3". All right, let's substitute. We'll just kind of work up here. I'm going to kind of keep all this here. And so pi is 3.14. For those of you that are kind of new to maybe calculators and that, I don't know. Let me see here. Right here, okay. I have a basic calculator. You can find this at, well, I don't know, almost everywhere, but you can definitely find it at Walmart. The symbol you're looking for is right there. Okay, and you have to use the second function button to access it. Really all you need to do is, so for our problem, I'll just continue here. 3.6, okay, and it's squared. Or you could just write it like this as well. It's kind of up to you. Basically means the same thing. Okay, so going back to here, so you have the squared symbol, so you could just type 3.6, press squared, right? It'll display that answer. And then you can multiply that by, you press multiply, second function, pi, and then equals. I have the calculator in front of me, but battery's dead. I have my other calculator, but it's more of an advanced one. So 3.6 squared equals, I get 12.96, just to let you know. We'll just carry the work down so you can see. So that when you're using your calculator that we're getting the same answers here, okay? .6 squared, and then I just gotta I hit enter, but if I hit multiply, it goes answer times. It actually recalls your last answer. It's still on display for me. And then all I have to do is hit second function, pi, and then enter, or equals. So therefore I get area of this circle is equal to 40. Now, I don't know, we'll just go to the nearest tenths because that's our accuracy as far as I'm concerned. Okay, I always use pi that's stored in the calculator because you're going to have a more accurate answer. If you just type 3.14, you're going to lose some accuracy. Okay, so I'm going to go decimal 7 because it's 7.1, and I don't have to round up. Okay, and what's our units? Meters. Now take note. It's only a singular meter, right? 3 squared. Yeah, meters squared. Sorry, guys. My bad. I don't know what I'm thinking. Okay, it is meters squared. because it's meters times meters. If you're not sure, you could actually look at it, right? Okay, I don't know what I was thinking or trying to say there, but at least I caught it. Okay, it's area. Area for the area is in squared units. Okay, so I could do the same thing if I wanted to know the answer, and let's go like this. I'll just kind of erase everything. Let me just erase all of this. I always do that. It's funny. Okay. So I'm going to convert 3.6 okay, and this, so 3.6, okay. 1 meter equals 3.28. I'm just going to use 3.28. It's actually 0, and that's feet. Okay. All right. So the quick way to convert it is like this. So put our ratio down. I'm going to put 1. Okay. This is meters. And this is feet, which is 3.28. We're using ratio proportion, guys. And it's equal to, what do we know? We know that it's 3.6 meters. Okay, so meters is up top. Therefore, this is unknown. Okay, so I'm going to erase this, because our radius is going to be something else, right? We're converting it just for funsies, because why not? So x times 1 is x. X equals 3.6 times, better go like this, especially if you have something with a decimal, it's best to use brackets. Okay, I'll work that out on the calculator. We're just converting right now. That's all we're doing. We're converting the meters to feet. So 3.6 times 3.28, that is 11.808 feet. So to figure that out, times 12, that's 11 foot 9 and 11/16 to be close. Okay, so I'm just going to keep it as a decimal. So now we're going to go like this, 11.808. I'm just going to keep the accuracy. That is squared. And so 11.808 Did I lose some accuracy? I get 11.811. So, I mean, I don't know. Somewhere I lost some accuracy. Could be here. I could be a little more accurate with this. I just typed it into my little Google convert thing there. But that's okay. Close enough. We're just practicing here, guys. Okay. So, I guess I think I could just type squared without brackets, and I should get the answer of 139. Decimal. I'm gonna go 429. I always keep whatever is displayed on my calculator. You want to save that information, right? You don't want to lose your accuracy. So now I just got to go times, second function, pi, and equals. And hopefully I did all my calculating properly. And I'm just going to round it to the nearest tenths, which turns out to be 0. And that is feet squared. Okay. Let's double check our work. 3.6. We're converting from meters to feet. Whoops. 3.6 times 3.28. Delete. I gotta fix my mistakes here. 11.808. Okay, so that should be feet. And then we substitute that in for our radius. Let's see if I can go bracket. Second function answer. Sometimes you can recall your answer. Yeah, second function answer. Close bracket. Squared equals 139.428. Rounding up, 429. And then take that answer and multiply it by second function pi. 438. Looks like we're good. Okay, I just wanted to double check because I don't have any answers. I'm just kind of creating problems, making up problems here as we go. So, you guys let me know. You smart, beautiful, intelligent people out there, let me know. Did I get the answer right? Let's go. Okay, so we basically took the same circle, we calculated it in meters, and then we converted the meters to feet, and went with it. You could even take that foot conversion and just convert it to inches if you want. It's up to you. It just depends on what kind of answer you want. So I put these notes here to let you guys know that pi, I didn't really finish it, but that's kind of what I wanted to talk about. Pi, I kind of briefly talked about it, but I wanted to make sure you guys understood that, it's the ratio of circumference divided by diameter, right? Okay, which is true. And it's also a constant, okay? Unchangeable. And do I have what is pi in simple words? Succinctly, pi which is written as the Greek letter for pi, for pi, is the ratio of the circumference of any circle to the diameter of that circle. That's the kind of the basic. The number pi is a mathematical constant, approximately equal to 3.14159. That's the accuracy of it so far to date. Okay? That is the ratio of a circle's circumference to its diameter. Okay? This is what I'm talking about, m over n. Okay? Rational numbers. All right, what else do we need to know? Scientific American. They have a little. What is pi and how did it originate? We kind of talked about that a little bit. Again, remember, pi is, it's an irrational. Rational number, okay? So if we wanted a little more accuracy, it would be, it's a little crazy that we honestly just use pi on your calculator and it'll actually use all these digits instead of having to type it all the time. Okay? You can use 3.14159, 5 significant digits. You would still get pretty decent accuracy. 265. I mean, this goes on forever. 265, 358. 979. Just want to make sure I don't mess it up. Okay. 3238. Whoops. My brain's thinking faster than my writing. 3, 2, 3, and 8. Oh, just squeeze it in there. Okay, it still goes on longer than that. Of course, you can't type that many digits into your calculator screen. How many spots on a screen anyways? 3.14159. I guess with my calculator, I could actually type all that. But a basic calculator, what do you get? 7, 8? I can't recall. With mine, I could type all that. But again, just use the symbol of pi on your calculator and you will get all that accuracy, okay? All right. A little bit of history, couple of examples in the metric system, using the metric system and the imperial system as well. Okay, and I'm just going to erase this here. I put that there just to remind myself to talk about it. All right. How are we doing for time? Do we have time for more? Hope you guys are enjoying what we're doing, I hope. I'd like to make it more fun, a lot more fun. I don't know, I can't really jump and do backflips and cartwheels. We're at 40 minutes. could do a lot more problems. I have a lot of practice examples. I'm going to try to skip a bunch and then try to get to the review. Wow, my kid's been doing good. He's been doing some of the word problems. Look at him. Oh, right. I think I was helping him with that one. That's what you kind of need to take this to. Like, it's great to just practice some examples, but it's another thing to actually utilize it in a real world. Okay? Take note, guys. You can't take a physical measuring tape and measure something to 3.567. There's no measuring tape out there that'll do that for you. Okay? You will not find one. Okay? Digital calipers. They kind of look like this a little bit, something like that. I don't know. I'm just going to go like that. Okay. Now these will have a digital, right? That's how you get accuracy, is from a digital caliper, right? But they can only measure. They're great for machinists or whatever, somebody that wants the accuracy of measurement. But in the real world, you're just going to measure something to fractionals, right? What's 5.625 is 9/16, right? Right? That's the best you're going to get with a measuring tape, okay? Now, all you can do is, to get some accuracy, the only thing you really can do is this. Well, obviously, we know what 3 9/16 is in decimal form, right? Oh, come on, click. 3.5625, if I recall. I'll just double check that. 9 divided by 16. Yeah, 56.25. Okay. Now that's how you can get accuracy, I guess, from a measuring tape. Really just converting the fraction to a decimal point or a decimal value. So yeah, that's just a little bit of tips, advice, kind of real world stuff. I'll leave it at that. I'll have to kind of figure out what else we're gonna do. Yeah. Alright, stay tuned, guys. I'll figure it out for next video. I'll try to kind of skip some sections here. We'll try to, turn it up a notch a little bit, okay? I don't want you guys getting bored. Hopefully you understand so far. Support you in your mathematics journey, every single one of you. Wish you to do your best and to, have great results. Okay? I mean that. All right, support you parents that are homeschooling your children or child, and also students that are looking for additional support here in YouTube land. So it's great to have you. I'm Johnny, WhiskeyTango Sharp. I mean, technically speaking, I could do coding and mathematics. So, I don't know, it's a mixed channel. That's all I'm really getting at. I'll see you guys in the next video. Have an awesome rest of your day, and take care for now. Peace out.